Welcome back to my ongoing seminar series. Today we'll be discussing a planet that no longer exists.
So what happened to it?
We are standing on it. Let's begin. 4.5 billion years ago, the solar system was still in its infancy. There were no planets, no moons, no convenient little labels telling everyone where they were supposed to orbit. Instead, there was a vast cloud of gas and dust collapsing under gravity. As the material began to coalesce, tiny grains collided and stuck together. Those became pebbles. The pebbles became rocks. Those rocks became large rocks. And eventually, gravity began introducing increasingly larger rocks to one another at considerable velocity. The young solar system was an enormous cosmic construction site. Except the construction equipment was mostly rocks, traveling at several kilometers per second.
Stop saying rocks.
Hundreds of planetary embryos were forming throughout the inner solar system. These were large bodies, some hundreds or even thousands of kilometers across, competing for the same limited supply of material.
You might say they were big rocks.
Very big rocks, actually. Eventually, some of these rocks became planets, others became moons, asteroids, or debris, and some simply ceased to exist after being struck by even larger rocks.
How did anything survive?
By being the thing doing most of the hitting. Over millions of years, these collisions gradually cleared the debris and allowed the largest bodies to dominate their surroundings. Eventually, a handful of them became the planets we know today. Earth was one of them, and somewhere in the chaos, another planetary embryo was growing. Its name was Theia.
I've never heard of it.
Precisely. Theia was probably around the size of Mars and formed somewhere in the same general region as the young Earth.
So it was another planet.
More accurately, a planetary embryo. It was still growing, accumulating material, and gradually becoming a larger planetary body. Theia may have occupied an orbit that was relatively stable for millions of years, allowing it to coexist with the young Earth.
So Earth had a neighbor, a friend.
Essentially.
And nobody remembers it.
We remember it, Kirsch. We remember it, and its contribution to lunar formation. For a relatively small world, Theia would leave a remarkably lasting legacy. Theia has one other distinction. It was named after Theia, the Greek titan associated with sight and the shining light of the sky, and mother of Selene, the goddess of the moon.
That's actually rather fitting.
Eventually, the young Earth and Theia crossed paths. Unfortunately, they were traveling in rather different directions. Theia struck Earth at several kilometers per second. The collision released an almost incomprehensible amount of energy, violently reshaping both worlds. Vast portions of their outer layers were heated to thousands of degrees, melting and vaporizing enormous quantities of rock. The young Earth was effectively turned into a world of molten rock, surrounded by a cloud of vaporized material and debris. Any oceans that existed before the impact were destroyed.
The oceans were destroyed?
They became steam. The impact also blasted enormous quantities of molten rock and debris into orbit around Earth. For a time, the planet was surrounded by a vast cloud of material left behind by the collision.
That's horrifying.
Yes, just another Tuesday by early solar system standards. But something rather remarkable happened next. Gravity began doing what gravity does best. It started putting everything back together. Small pieces collided and merged. Those pieces formed larger pieces. The larger pieces formed an increasingly substantial body.
So it was basically assembling itself.
Correct. Over time, this process of accretion produced a single large planetary satellite, the Moon. The exact details of how the Moon formed are still being investigated, but the giant impact hypothesis explains many of its unusual characteristics remarkably well. Meanwhile, the Earth was beginning to recover. Its surface gradually cooled, molten rock solidified, an atmosphere began to develop. and eventually water returned to the surface. The planet had survived one of the most violent events in its history, and it had acquired a moon in the process.
That's quite a recovery.
Yes, although I imagine Earth would have preferred a less destructive method of acquiring one.
Couldn't it have just bought one?
There were no shops, Kirsch.
Oh, right. I knew that.
Which means that one of the most familiar objects in the night sky may ultimately be the remains of two planets that violently destroyed one another. So how do we know any of this actually happened? Unfortunately, nobody was around 4.5 billion years ago to take notes.
That's a shame.
Quite. Instead, scientists have had to reconstruct the event from the evidence left behind. One of the most important clues came from the moon itself. During the Apollo missions, ancient humans collected hundreds of kilograms of lunar rock and brought it back to Earth for analysis. When scientists examined those samples, they discovered something remarkable. The moon and Earth have extremely similar isotopic compositions.
Meaning?
Atoms of the same element can have different numbers of neutrons. These variations are called isotopes. The precise ratios of those isotopes act rather like a chemical fingerprint, and the fingerprints found in lunar rocks are remarkably similar to those found in Earth rocks. This strongly suggests that the moon formed from material closely related to the young Earth.
Which fits the giant impact.
There is another clue. The moon has a relatively small iron core compared with Earth. If the moon had simply formed independently somewhere else in the solar system, we would expect its composition to be rather different. Instead, it looks surprisingly like a collection of Earth's outer material. Then there is the moon's motion. The Earth and moon orbit around a shared center of mass, and the entire Earth-Moon system carries a tremendous amount of angular momentum. A giant collision provides a remarkably good way of producing that particular combination of rotation and orbital motion.
So the moon isn't just evidence because it exists.
Correct. Its composition, structure, orbit and motion all provide clues about how it came to exist. Scientists can then take those observations and construct computer simulations of the early solar system. They can vary the size of the impactor, its speed, its angle of approach, and the conditions of the young Earth. Some simulations produce a moon remarkably similar to the one we observe today.
And some don't?
Of course not. Science would be considerably easier if every simulation produced the correct answer on the first attempt. The important point is that multiple independent lines of evidence are consistent with a giant impact.
So we're fairly confident this is what happened.
We are confident that the evidence supports the hypothesis.
That's not quite the same thing.
Correct. Which brings us to an interesting question. Could Theia still exist somewhere in the solar system?
After all that?
Not as a planet. Theia was almost certainly destroyed as a separate world during the collision. But that does not necessarily mean that Theia disappeared completely.
What happened to all of it?
Some of its material would have been incorporated into the moon, some would have become part of Earth, and some of it may still be buried deep beneath our sprouts.
Beneath Earth?
Possibly. Deep inside Earth's mantle are two enormous regions known as large low shear velocity provinces.
That's quite a name.
Scientists generally call them LLSVPs.
That's even worse.
Correct. They are enormous, unusually dense regions located near the boundary between Earth's mantle and core. Their origin remains uncertain. But one possibility is particularly intriguing. Some researchers have proposed that these structures could contain substantial remnants of Theia.
You're saying part of an ancient planet could still be inside Earth?
It is one possibility being investigated.
After 4.5 billion years?
Earth's mantle is extremely good at keeping secrets. If the hypothesis is correct, then Theia did not simply vanish. Fragments of that lost world may still exist inside the Earth, while other material became part of the moon.
So Theia is still here?
In a manner of speaking, The planet that disappeared may have left pieces of itself scattered across 2 worlds, and some of those pieces could be sitting thousands of kilometers beneath your sprout.
That's actually rather amazing.
Somewhere beneath us, the remains of a world that existed before humanity, before beings, and before almost everything we know may still be waiting.
That's creepy.
Science often is. Class dismissed.